Hello, my name is Yaron Chen, and today we're going to talk about managing electrical vehicle charging solution stations by using machine learning. Again, electrical car, as you know, is gaining momentum. A lot of cars also in the US and in other countries are increasing more and more on the roads, as well as charging stations to supply the demand and to provide the mobility of the electrical vehicles. There's a lot of charging stations are being deployed in many countries and cities and highways in order to support the traffic. Also, the energy providers and the grids also making a lot of preparations to support this in the future. And charging providers that usually have big parking lots also are deploying charging stations. And it's becoming a very big business, both in the US, in Europe, and also in my country, Israel. So, what are the problems that we need to solve, and who is the target users? So we're talking about the EV CFOs, which are the electrical vehicle car fleet owners. It's usually companies that own parking lots and have a lot of charging station in the parking lot in order to provide the energy. And the dilemma that these users are having today is the ability to predict how much energy I can provide to every charge station. And can I also offer our customer the ability to reserve at least 2 days in ahead a parking spot and enough energy to charge their car, at least let's say to 80%, so they can go to another city, be sure that they have a place to charge their car, and they can come back home safely without being stuck. So today the EVCFOs actually don't have this ability to predict not the amount of power that they're going to get from the energy providers. It could be like fuel energy providers or green and renewable energy resources, and the ability to predict the amount of energy is very limited. Also, they cannot predict the number or give the ability to the customer to reserve spaces. They can actually only use their minimum ability of minimum energy that will be distributed between the cars. They don't actually know how much energy are these cars coming with, so they cannot promise anything. And what actually is happening that there are revenues are decreasing because they cannot fulfill the maximum energy that they can provide. So we have what is the factors that actually deciding the amount of energy I can supply for every charge station. First is the human factor. We have people that are reserving spots. The estimation like they will be there for 3 hours and they show up like after 8 hours. So this spot cannot be reallocated. Also, we need to know how much energy they already have in their batteries, and they can not tell the truth in order to speed their charging on the expense of others. We have force majeure like pandemics, national security issues that might change the people that are going to come to our parking lot and the amount of energy they have. And also it also reflects on the ability to generate power. Let's say if we have a pandemic, people stay at home, and maybe we have more energy in the city center that are not used by offices and stuff like that. Changes in the market. Every day they introduce companies introduce new electrical vehicle cars with different capacity and their ability to store more and more energy and charge in a very fast or slower time. And also this needs to take into account. The metrics that we are going to actually measure is how much can we predict the amount of energy that we can consume. Let's say, for example, we have currently like, I don't know, 15 kilowatts assured energy, and we can have another 50 energy, which is not guaranteed to us, but we can use it as we if it's available or not. So if we'll be able to consume all this energy, it will be increasing our revenues, and also it will be increasing our customer satisfaction. Our customers know that they are coming to our parking lot. It means that we are able to predict and provide them the service they need, and also give them a good estimation how much time it will take to charge their car, so they can manage their time better when they're visiting the city or the spot they need to charge. Our targets is to increase our revenue in 25% by being ability to predict and to commit to energy, and also to predict right the amount of time that the car needs to be charged, and by that increasing our customer satisfaction, and that we can measure with questionnaires and stuff, and also see how many people are coming to if it's increased the amount of customer coming. The constraint is that we need to at least have 2 days the ability to predict in advance, so people can order their charging spot at least 2 days. Sure, they can do like in an hour or two, but that's easy, but 2 days, it's a little bit complicated. And the decision regarding the energy should be next to real time, because we need to decide what charging port in our parking gets, how much energy every charge point gets in real time. And the learning should be on daily basis, because as we said, we had a lot of factors coming in all the time, and we need to adjust it very, very fast. So these are the sources that we're going to get the data from: the weather provider, traffic providers, the energy from our energy providers. Usually they have some kind of prediction that they already acquire by themselves, and the history of the charging in our parking lot. And maybe we can also cooperate with other parking lots and get all the information: what is the demand, what kind of cars are coming, how much time it takes to charge every car, and so on and so forth. So looking at the architecture, we see that we are taking the information from all the providers. We need to sanitize the information so it will be right for our machine learning machine. So all this information will get into our machine. First, it's going to visit, our big query database. So we're going to collect all this data all the time, so it will help us do the training for and improving our network. And also the decision of the network will also be stored in the database, so we can also see how we are coping with the actual prediction versus what's actually happened in the real time, and learn from that. So in this slide, you can see that we have a lot of charging parking lot with chargers along the city. The city of Tel Aviv is next to the city I'm living here, and because they are spread along all the area, they might spread all over the country. We have a cloud-based system that actually all the charge points are connected to this system, and this system is managing it. In the system, we also have the interaction with the actual customer that doing the reservation, activation, and deactivation of all the charging transactions. We have, as we said, the database that collects all the events and all the information. As we see, we're using here some kind of a bus that all the events are generated and received by all these services in our cloud station. And again, the machine learning here is the one that actually give the prediction and tell the power management unit in our system how to distribute the energy between the parking lots and the charge points in the parking lot. In order the system to learn in real time, we're actually going to have like two networks. One of them is going to learn while the other one is functioning, and then we're going to replace them at real time every few hours or few days. So we're always going to learn more and more and adjust to the frequent changes of the factors as we already described. So what the risk that we have? The risk that we have is that, as we said, we have many sources of data, and they're very complex. It means that the models need to be very complex. It's not easy to predict the estimation of energy per every charge point in every parking lot. Knowing the right behavior of what is the expected behavior. So we actually need to think about all the scenarios that we might have and what should be the exact solution. This is not easy to simulate and train the network according to the right thing that we want her to do. And we might also encounter some missing factors that we didn't thought in the beginning of our construction of our model, and we might find later that we are not able to predict because we are missing some kind of a factor that we need to think about all the time. Second, the topic of risk is data drift. As we said, we have a lot of factors that can change along the time because of pandemic and because of, especially in Israel, we have a lot of security issues that might change the way that the traffic and the availability of people and how many people are getting into the city, or maybe they stay at home and work from home. Another parametric is that a lot of our data is coming from the actual users. Users can learn that the system, they might learn how to trick the system and how to be a wise guys and use the system believe in them, and they might lie about their battery capacity, or maybe not showing up, or coming when they are not invited and stuff like that. Governing and monitoring is a very serious issue, because if we will draw too much energy from our energy providers, that might cause a blackout, because we will draw too much energy. The provider would actually drop us from the grid because we are causing too much problem, and that might cause an outage to all the parking lots, and by that we will be failed to provide the service that we are promising. And for that, we need to develop a governing and monitoring system to make sure that the prediction that we provide from the machine learning will not actually exceed the amount of energy that we are allowed to take at any given time. And if it's happened, then we need to stop our machine learning, or maybe disregard his decision with regards to one charge point or several, in order not to get across the maximum power that we are allowed to take. So thank you very much for listening to this lecture, and see you. Thank you.